Okay, the last problem in the packet. This is 2007, question number 2. Again, it's a calculator question. We've got this graph. This question is talking about the amount of water in a storage tank in gallons is modeled by a continuous function on the time interval from 0 to 7 where t is measured in hours. In this model, rates are given as follows. The rate at which water enters the tank is f of t equals 100 t squared times sine of the square root of t gallons per hour from 0 to 7. So that's the rate at which water enters. Key word there is enters the tank. And then we also have the rate at which water leaves the tank. And this function is actually a piecewise function. It's also a constant rate function. So it's 250 when t is between 0 and 3, and then it goes up to 2,000 for 3 to 7. On the graph, that rate that water is leaving, I'll color that in blue. Oh, I didn't want to cover that in blue, sorry. Try again. The rate that water is leaving, if I do that in blue, those are these horizontal lines. And then the rate that it is entering is this curving function here. So that's f of t. It says the graphs of f and g which intersect at t equals 1.617 and t equals 5.076. Super handy. They tell us the t values of these intersection points. So this is t equals 1.617. This one is t equals 5.076. They are shown in the figure above. At time t equals 0, the amount of water in the tank is 5,000 gallons. So a lot of stuff to even take in before we've even been asked a specific question. Part A says, how many gallons of water enter the tank during the time interval from 0 to 7? Now specifically, this question is saying, enter the tank. Because it's saying enter the tank, we are only concerned about the function f of t. On the interval 0 to 7, then it says round your answer to the nearest gallon. So again, how many? This is the common question. How many? I need to integrate over the rate. So we're going to do the integral from 0 to 7 of our function f of t dt. And that comes out with a rounded answer. I'll do approximate here because it's not exactly that because we're rounding 8,264 gallons. This is a 2-point question. We get 1 point for the integral, and we get 1 point for the answer. Moving on to question B. Question B. For t between 0 and 7, find the time intervals during which the amount of water in the tank is decreasing. Give a reason for each answer. Now, if the water in the tank is decreasing, that means that the water leaving is greater than the water entering. So the question is, where does that happen on the graph? Where is the water leaving greater than the water entering? And on the graph, it's the time periods where those horizontal functions, which represent water leaving, are higher up on the graph than the other function. So that's going to represent this part right here and this part right here. On those intervals of x values, that is where the amount of water leaving is greater than the amount of water entering. Luckily, we have those intersection points. So we could say the amount of water in the tank is decreasing on the intervals from 0 to 1.617. Now I'm going to include 0 because we know at 0, we know exactly what's happening at 0. At 1.617, they're equal, so I'm not including that value. And the other interval is going to go from 3 to 5.076. And our rationale for this, we'd say the amount of water in the tank is decreasing on the intervals. We give the intervals because f of t is less than g of t on those intervals. This is a 2-point question. You would get 1 point for having both intervals correct. And then you've got 1 point for your rationale. So 2 points for part B, 2 points for A. That leaves 5 points for question C. Right, question C, it says, for t between 0 and 7, at what time t is the amount of water in the tank greatest? The amount of water in the tank the greatest. This is getting at the concept of an absolute maximum. And it says, to the nearest gallon, compute the amount of water at this time, justify your answer. So we need to go through the process of finding an absolute maximum, which is trying to figure out where the critical points are, and then looking at the endpoints as well. So here's what we can think of. If we're looking for an absolute maximum, maximums in general are where you have a sign change from positive to negative. So what I'm going to do is I'm going to look back at the graph, and I want to look at where our rate changes from increasing to decreasing. On our graph, we identified these 2 parts that I've shaded in are where the water is decreasing. The other intervals are where the amount of water is increasing. That means if I'm looking for a shift from increasing to decreasing or positive to negative, and we want to look at it, that's going to happen at this point. So this is our critical point. And that is at t equals 3. That'll be the first thing we'll say. We'll say critical point at t equals 3. Now our other 2 possibilities for where this maximum can happen are at the endpoints of 0 and 7. So I'm going to create a table. And I'm going to call it t and a of t. So I've got 0, 3, and 7. A of t, that just stands for the total amount of water. Now, at time 0, we were told that we started with 5,000 gallons. So I'm going to put in 5,000 there. That's our amount. That's the easy one to figure out. For 3, we've got to take into account a few different things. We know we start with 5,000 gallons. But then we have water coming in and we have water leaving. The amount of water coming in, I can figure out by doing the integral from 0 to 3 of f of t. Then I also have water leaving. Now that water is leaving at a constant rate. And up to 3, that constant rate is 250 gallons per hour. So now I'm going to subtract 250 times 3. So it has what I start with, what I gain, and what I lose. All that happens in those first 3 hours. Working all this out using your calculator, this comes out to be 5,126.591. Okay? Now, on to figure out how many gallons of water are in after 7 hours. There's a couple of different ways that we can do this. We can do the exact same process we did in the previous one, or we can say, well, I know from 0 to 3, I've got 5,126.591. And now I just have to add and subtract what happens with the water from 3 to 7 hours. So to this amount, I'm going to add what we've accumulated from 3 to 7. And I'm going to subtract how much we lose from 3 to 7. And from 3 to 7, we're losing 2,000 gallons per hour. So I'll do 2,000 times 4, because we had 4 hours over those between 3 and 7. This number comes out to be 4,513.807. My conclusion then, and again we go to the nearest gallon, I would say the maximum amount of water in the tank is 5,127 gallons. So I said before, this was a 5-point question. Here's where you're going to get your 5 points from. You're going to get your 5 points for identifying t equals 3, so that's a point. You're going to get a point for doing this part of the work properly, meaning that you handle the rates properly when you're calculating the total amount. You get a point for this value and the value at 7, and then you finally get a point for your conclusion. And that's where the 5 points comes from.